Well, how was that for an introduction? Everyone has been asking me when the trains would start running. Of course, I've done 11 episodes now, and it's all been about building things and building parts of the layout and building the project building and stuff. But I'm happy to report that after a couple of weeks' absence from here, I've been very, very busy completing the staging yard. The staging yard is all done. It's all wired. And I have been learning digital command control. It is a completely new technology to me. It's been around for about 30 years, but it's been gradually evolving and improving. And now it is the dominant way to run a model railroad. And in that opening clip, you saw an advantage of the digital command control gives you, a greatly heightened realism. All the sound, if you have a higher end decoder like the locomotive that you saw, number 1427, which is a Union Pacific, it's called an MP15. It's a multi-purpose locomotive, primarily a yard switcher, but it came from Athearn Genesis. It's another Athearn Genesis model, but like my steam locomotives, it has a fully equipped sound decoder. And you couldn't do this without digital command control, DCC as we call it. And the sound files in there are actual sound files of real Union Pacific MP15. So the prime mover diesel engine sounds you heard were from an engine just like this one. The bell, the horn, everything copies a Union Pacific MP15. I've also got a Southern Pacific MP15, which I'm not going to have on screen right at the moment, but it differs somewhat in details, outside details with certain fixtures and everything, and it also differs some in some of the sound files because Southern Pacific uses different type air horns, but it would be very realistic to have this locomotive on my layout because Union Pacific absorbed Southern Pacific, and for quite a few years before it absorbed Southern Pacific, they were running Southern Pacific motive power in preparation for the merger. But this past couple weeks has been devoted to finishing the staging yard, finishing the wiring, which is a very meticulous process, and finishing all the track, making sure everything works right. A lot of circuit testing, finding a few glitches here and there, but actually it's been gone quite smoothly. There were a couple of loose connections I didn't anticipate, and a couple of buttons I had to replace, or things I had to replace, but everything's working exactly the way I hoped it would work. With my selective power routing. I'm very happy with it. A large part of the work here has been studying digital command control, DCC. As I said, it's a new technology I'm moving into. It has enormous advantages, but you really have to know what you're doing. And fortunately, there's a great deal of help available in it. The manufacturer that I'm using, North Coast Engineering, or we call it NCE, which is their main power cab here. This is control, and they have an excellent technical support site, a technical support staff that you can call on, and also there are other online communities that really help with this, so you're not on your own in this. But to talk a little bit about DCC, what it involved, and also what I went to put this up, I have to go back and talk about how we used to control trains and the old the old technology that had been running electric trains for, and still runs. A lot of people with basic layouts use it, and some with advanced layouts because they just don't want to learn something new in DCC. So it's been around about 100 years, more than 100 years, and this is basically true for both AC and DC operation, although scale model trains generally all use direct current, the traditional control system. So these following graphics will show you some of the main components. The first is a power pack, a very inexpensive $30, $40 power pack. Anybody that's bought an HO train set is familiar with these. They run off 110 or 220 volt AC wall circuit. They transform it down and rectify it to DC. The track voltage, this unit I'm showing here, basically has two fixed terminals for DC and two variable terminals. The variable terminals go to the track. And they vary voltage from 0 to approximately 12, 14 volts. And that controls train speed. It's just that simple. Two wires hooked up. The one advantage DC wiring has is it's very simple. Anyone can do it. But the simplicity has a price with it because you don't have the advantages you have with DCC, not nearly. And there's difficulties with layout wiring associated with it, some of which I'll talk about. The big disadvantage it has is that you have to have an electrically isolated block of track in which you're running the locomotive. If you put two locomotives in that block and they're on different trains, they'll both accelerate or decelerate as you move the controls. So you can't really copy how real railroads operate. And one of the things we say about DC controls, you spend more time running your layout than you do running your trains. So you always have to make these very unrealistic considerations about routing power and everything that don't happen on real railroads. But as the graphic shows, basic DC setup is polarized setup, positive on one rail, negative on the other. And your speed control is done by varying the setting on the potentiometer to change the track voltage, which will speed the train up or slow it down. And then also, to reverse the train, you have to reverse the polarity. There's a reversing switch, which basically reverses the polarity on your wire feeds. One of the main problems that comes from this, as it shows in the next graphic, is that when you have a situation where you have a reversing loop, or a crossing reversing, as you see in this graphic, and you can see by the colors in the graphic, where the rails are going to join with rails that are polarized in the opposite direction, you're going to have a short. So even though you might want to do this with a layout, because you have two rail and each one is carrying a different polarity, you have to make allowances in your wiring, and that gets involved in some switches, very unrealistic kind of things you have to do to switch polarity. And it's really kind of a pain. And again, you become more wrapped up in running the layout as opposed to running the trains. And it's a real barrier to realistic operation. Now, talking about DCC, one of the nice things about it is, as with everything in model railroading, the National Model Railroad Association sets the standards for model railroad equipment, how it operates, all the standards for appearance, everything. So one of the nice things about model railroading is that, when you buy something by any manufacturer and they have the NMRA standard seal on their package, that it complies with the NMRA standards, which are called recommended practices, RPs, and they go down to even such things as the profile of the wheels, coupler types, everything. So everybody's equipment operates with everybody else's equipment as long as it's all built to the NMRA standards and practices. When it comes to DCC, as we see on this graphic, there is a separate DCC working group at NMRA, and they have set the standards for digital command and control. Now, the thing that's nice about this is that any DCC receiver equipped locomotive will run on anyone's DCC layout, regardless of who makes the DCC system. Now, one of the things about the DCC systems is that the system itself, the architecture, is really particular to each manufacturer. They're proprietary. The nice thing about it is once you get past that architecture into the rails, everything is common, and this is set by the NMRA standards. So I'm running NCE, which is one of the two big gorillas in the market, U.S. market. Another German manufacturer, Lenz, makes a good DCC system too. Digitrax is the other American system, but I can take my NCE equipped programmed locomotives, set them down on a Digitrax layout, and they'll operate because they operate on the same command signal packets, and that's a really good feature. And one of the nice things about, and this is set by the standards of the DCC working group, as you see by that emblem on the slide. The third emblem there is the DCC Wiki, which is really pretty neat. DCC has its own wiki page. Wiki pages are quite voluminous, run by a number of people. Mark Gurrius is one that comes to mind. And you can get any question, however wild you might imagine it, answered on there. What do I do if I have this? What do I do if I have that? What's happening here? And this has been a great help, because you go in there with a question about how do I do this? And you can go in the list of questions, and there's thousands of them, and you'll find the answer there. Or you just throw the question out on a blog, and within hours you'll have multiple responses back. Oh, you need to do this. And so you've got a lot of good hand-holding to work your way through this. One of the other things I want to mention about DCC is this next slide shows the basic architecture, and this is where you have to really start thinking about how DCC works. And you'll see on the left side, it's a simple installation, and you can get a simple integrated command station, looks much like a power pack, traditional DC power pack, and it plugs in the wall, and you have 2 wires to connect to the track, and you can control DCC decoder equipped locomotives. You notice there's a decoder in each locomotive, and there's also notes as a sound board. Not all decoders come with sound function. You can add it to a lot of locomotives. You can buy independent sound boards, or like these Athearn Genesis units, you can buy decoders that have integrated sound functions. Either one works just as well. Obviously, with a sound decoder, sound equipped decoder are much more expensive, and I'm not sure I'm going to put sound in every one of my locomotives. If you have 8 or 10 locomotives on a layout and all the sounds are running, it can get kind of cacophonous sometimes. So, but it's fun to be able to hear it in one locomotive you're running. But that's a simple installation, and that is what I basically started with here, with the intention of expanding. Now, when you go to the right side of the slide, or right side of the graphic, that's an advanced installation, and that's what I'm really building towards here. And the nice thing about NCE is it's very, very forward compatible. You can start with a very basic system, which is what this one is here. This is called the NCE Power Cab, and this is their basic starter system. And essentially, it's like the graphic on the left. It's a simple system, but all of the function is in that power pack is in this handheld control cab. So everything on the bottom left part of that slide is in here, and it just plugs into a power supply, and then through this panel 2 wires go to the track. This will run multiple locomotives. You can control them independently by selecting which locomotive. You have one layout where it's all one giant electrically connected block, and you can command each locomotive to do something different. And this is the power cab. The nice thing about it is, that I'll talk about here in a few minutes, is that it's the basis for expanding into a much more complex setup, which is described on the right side of the graphic, which basically shows the radio control transmitters, receivers, power command station, power modules, multiple locomotives, and then you can get really interesting. And that's what I've done here. I've actually got 2 of NCE's, what they called handheld controller, Power Pro, a Cab 06R, which allows me to control the locomotives. You notice there's a cord connecting this to the layout, a 14, 15 foot phone receiver type cord. This is completely wireless. And if you notice up here in the ceiling, you'll see there's a wireless base station, and it's connected to the command station. It's a radio broadcast, it's a receiver transmitter. And the commands go from these 2 handheld throttles through that base station to the command station to send the command out over the rails for what the train is supposed to do. And to enable coverage on layout, this has an effective range of about 25 feet with what's called a toroidal signal pattern, basically a donut. And it would possibly cover the whole area of my layout, but to ensure that I get full coverage, I've actually put in 2 repeaters, which are slave to this. There's a repeater over there, and you might be able to see in the far distance there's one over there, so that at any point that somebody's walking around with one of these handheld throttles, they will always be talking to at least one, and on average 2, and sometimes all 3 of the radio repeaters or base stations, so we won't be breaking any signal path. But this has all the functions that has, and it's wireless, and I can walk along with my train. Now the nice thing about it is 2 people can be running trains independently on this layout, just like engineers in a real train, and they can operate it, and it's really neat, and it's fun. I played with this, and I've got the wireless section system set up. A couple other things I want to talk about with regard to the DCC operation are in these next couple graphics. The first is the size of the receivers themselves. You'll notice here's a receiver compared to the size of a dime. This is an HO receiver to go in an HO locomotive, and it is the size of a dime. Not even quite as big as a dime, maybe about 3 times as thick. So they're easily placed in a locomotive. The wires are all color coded. Again, all these wire connections are standardized by the National Model Railroad Association, so anyone's receiver will plug into any manufacturer's locomotive harness in exactly the same way. So you could be assured that whoever you buy your receivers from, and there's probably a dozen manufacturers of receivers, that you can plug it into a locomotive and it'll operate on DCC. But obviously space is not that much of a concern with it. Now, this is not a sound-equipped receiver. It's a basic receiver, but still a very good one. And it'll allow you to control independent headlights and all the functions of the locomotive, with the exception of no sound capability. A sound receiver is probably about twice the size of this, still not very big, and you have a micro speaker that you have to put in the locomotive, and there's a real art to doing that, because you have to baffle it and do certain kind of things, and that's something I haven't learned how to do yet. So the other thing I wanted to point out in this next graphic is the signal that comes to the locomotive to command the receiver. And now this is called a packet, a command packet. And the DCC systems have 255 command packet variations. You can have up to 255 locomotives on one layout. Well, nobody's going to have 255 locomotives. I've got about 4 dozen, and that's a lot. And I've acquired them over the years. But the command packet is addressed to a particular receiver and a particular locomotive. And you do that by setting up the address in the locomotive to respond only to its command packet. And these are repeated 60 times a second. They go through the rails, they're superimposed. The track power on DCC compared to DC is constant. It's a constant 13.8 volts. Okay, so it doesn't vary the track power. The variation comes in what the receiver is commanded. The receiver essentially acts like your hand turning the knob on the power pack, turning up the power, turning down the power, depending on how fast you want to go and what direction you want to go. So there's no reversing polarity on the rails, there's no varying the voltage on the rails. The key to the command control system is the digital packets that come over the rails. The system produces 256, or 0 to 255, but a total of 256 command packets. But the 0 packet, again, all these packets repeat 60 times a second. The 0 packet is a parity check. It checks the system, makes sure that it goes through. The signal that goes to the locomotives is actually its command repeated 4 times. So to make sure the locomotive gets it, and there's another feature called back EMF, which is essentially the locomotive talking back to the system and making sure that it gets the commands. Again, a lot to learn. If you can see part of the basement over here in my man cave by the TV, I've got a bunch of tech manuals spread out. I've been studying this actually for a long time, but the last 2 weeks, anticipating where we're going, I've been very intensively studying it. So with that, we'll change camera position here, and I'll show you some of the components of the system. Okay, we're down here in the cave, I guess I call it, underneath the layout, and this is where the brains of the DCC system operates. I'm going to point out a few of the features here to you. I'm still, obviously you can see I'm working around this. But to start, this is the beginner system, the DC or the NCE power cab. This system is all self-contained. It's not that expensive compared to a lot of DCC systems. It has all the capabilities, just not a lot of power output, but it's very good for a small layout where you may be running 4 or 5 at the most locomotives, and it has plenty of power to handle that. You can hear I've got the system turned on and one of my locomotives running in the background, the sound of it. And the nice thing about this is that the way NCE has designed this system is that you can expand it. You can start with this as the base to expand into a very high-powered system that has all of the features that there are systems that cost $600 and $700 to purchase, and this is less than $200. And the way you do this is by adding certain pieces of equipment to it, and I'll go through some of the things here in the basic layout. So I'll put this back up here in the holder, my handy holder. And by the way, when this power cab is merged into part of a larger system, it basically reverts to becoming another control cab, because a lot of the command functions actually transfer to this device right here. And this is what's called a smart booster. And you can see the power light is on. So this has the capability to handle more locomotives. It has a 5 amp output. This has only about a 1.5 amp output. So right there you've got a lot more power to run the trains. And this is the power supply for the Smart Booster. This is, again, it's an SB3A Smart Booster made by NCE. Some of the other features down here, these over here on the board are power system, power districts. And one of the things you should do with digital command control, you don't have to, but it's a very smart thing to do, is to divide the layout up into power districts and then equip each one with one of these PSX smart circuit breakers, electronic circuit breakers, because one of the things that can be a problem with digital command control is that a short can cause real problems with the system. It can burn out some things. It can be pretty expensive to repair, so it doesn't happen immediately, but if a short persists, it can affect the system. And you can see the lights are on each of these. These are made by DCC Specialties. Each one can handle one power district. I have a number of others to install on the other side of the layout, and this is the one that is for the staging yard. This center one is for the branch line that I'm working on putting in now, and this is for a section of the main line. It's going to be about a third of the length of the layout. This is the DC power supply that supplies the power for the power switching relays on both ends of the staging yard. So this puts out a good clean 12 volts DC. It's got plenty of output to handle those relays and anything else that needs 12 volts DC on the layout. This is a good, stable, filtered power supply. Here is one thing that you really should get with a DCC system. This is a very good surge protector. It's one of the better models because you've got some pretty expensive electronics here, and just like a computer, you don't want a surge riding through it. And so all of the systems down here, all the power supplies, all the systems are plugged into this surge protector. Here is a laptop down here that I bought secondhand online. It had been refurbished on Amazon because one of the things you can do with DCC, when you install a decoder in a locomotive, you have to program the decoder. You have to give it an address, and you have to set a number of other parameters. And it's very handy to have this laptop running an application called Java Model Railroad Interface, and one of the modules of that is called Decoder Pro. And Decoder Pro is very good in helping you set up decoders and all the parameters in the decoders. The parameters are described by things that are called control variables, and there's about 90 control variables, some of which are fixed. You don't need to fool with, but some for like speed matching, which is one of the other advantages of DCC, is you can speed match all your locomotives. So when you couple two of them together, one that may be inherently run faster because of gearing, well, with speed matching, you can tailor that so that every locomotive has the same speed curve. And that's very handy. You don't have them fighting each other, but having Decoder Pro in here is a very good feature for setting your decoder parameters. And among other things, I've got this, one of the things that will come in handy about this power cab is that to set the parameters and the control variables, you use this in conjunction with a laptop on what we call a programming track, which is an electrically isolated piece of track. And I'm going to set one track in the yard with a switch, electrical switch on it, that can flip over, electrically isolated, and it'll become the programming track. And when you plug the power cab into its own power supply and not into the system like it is here, it reverts to running as a power cab. So all the functions are here in the power cab controller. And the handy thing about that is you can set up your locomotive control variables using this. There's a very long, rich menu of ways you can do this in the NCE documentation. So one of the things I'm going to do is retain the use of this as a programming tool for my locomotives. And this I could send this back to NCE and have it converted into a wireless radio cab, but I'm not going to do that. I'm going to keep the two wireless radio cabs for running on the bulk of the layout, and this is going to be my cab for running the staging yard and doing the programming and maintenance on the decoders and everything, and it'll work out real well. So this is what's underneath the table. A couple of the little things to point out: you can see all these track buses here. Each track bus, you have to be very careful in wiring it. One of the things about DCC is signal strength is very important to the receiver in the locomotive, and they recommend that no more power drop to the track, to the rails on track, no more than every 6 feet, because the nickel silver rail we use has a fairly high resistance. So I've got a power drop every 3 feet. The main power buses here are AWG 14 wire, American wire gauge 14. The drops to the track are AWG 18. These are solid, these are stranded, because stranded handles flexing, and they're more subject to flexing than the track feeds. But wiring this was quite a bit of work. But one of the things that was handy about this is I used red and black coffee stir sticks, the hollow plastic stir sticks, and I drilled the holes up topside, and then put the black lead is always going on the rail further back than the one closer to the front of the edge of the layout. So that's the way I'm using this mnemonic device, black and back, and that's helps me keep straight which lead goes to which track and which lead goes to what bus. So everything is all color coded black and red. You can see this black and red over there, because keeping this all properly aligned is really important. You have to be sure that you don't cross these wires. But this is the guts of the outfit, the working end. Oh, one of the handy things. This is called a ramp meter. It's made by DCC Specialties. Tony's Train Exchange has it, and it's a special meter with digital readout that comes in very handy for testing your track voltage, the amperage draw, because you have to look at what each locomotive motor draws. The nice thing about modern model locomotives is they're all using coreless DC motors, which have an extremely low current draw, 0.2 of an amp, if that, under load, even at full slip. So this is a very handy tool to have. I just started using it, learning how to use it, and I already appreciate it a great deal. So if you're thinking about getting into DCC, one of the accessories I really recommend you get is a ramp meter, and they come at various price levels. Among other things too, I'm going to be putting some additional holders up here for the radio throttles, and that's where I'll keep them. And that is the underside of the layout, and I think in a little bit, probably tomorrow, I'll finish some of the video with showing you topside what I'm doing. Okay, it's the next day now, and I'm going to finish up talking a little bit about the DCC system I put in, and then show you a little bit of where I'm going from here, my next part of the project that I've already started. And then I've got a little video of when Edie came over, our granddaughter, and we ran trains, and that was a real thrill for her. She had a lot of fun with that. As I said yesterday, the area that I was down in, what I call the cave, was over here underneath the layout, and there's a little bit of wiring to do yet for the digital command control for the main system architecture. And basically I'm going to be installing this DB5, called a dumb booster, on this other side of the layout over here, because of the length we have to run and everything that need the additional power, and the cable runs in here for the supply. Now this booster, this dumb booster, does not contain the processing capability of the smart booster, the SB3A. It's basically just a slave unit that takes the command signals generated by the SB3A and adds its own 5 amps. So I have a total of 10 amps of 13.8 volts on the track. So that's a pretty good amount of current to run however many locomotives I'll have on this layout that'll be running at any one time, and particularly with the sound decoders. So this DB5 will be placed over in this area, mounted to a shelf under a column underneath here, and this is the 40-foot control cable that runs from the SB3A to the DB5. This was made up for me by North Coast Engineering. They make these cables to order, depending on how long you need them. This 40 feet is not an unusual length. You're only carrying a signal in here, you're not really carrying power, so the signal stays pretty clean over that whole length. And then of course there's a special regulated power supply that plugs into the booster and into the wall socket or into a surge protector, because this needs to be protected. And then one other thing I'll put underneath with this is, I mentioned yesterday, the PSX DCC Specialties PSX Intelligent Circuit Breaker, and this is going to go on the board just above the booster, and this will feed the various power districts on this side of the layout, and there will be at least 4 districts. I still have some of these in reserve in case I need to add more. The interesting thing about these PSX units is that they come as a single unit or a double unit or 3 or 4. And what you can do is they're actually scored between the units here. So if you need to separate them, you say you have a 4 unit, you want to put one off at a different location, you just bend the circuit board here gently, and it's scored to break off, so it'll break. There's no connections across the circuit boards in the back here. These are really necessary things to have with digital command control. They are very sensitive. They're intelligent. They will reset after a period of time. If they still detect a short, they will trip again, and they won't subject any of the more sensitive components of the system to short circuit that would damage it. Well worth the investment to get these. If you're going to go to DCC, this should be one of the first accessories that you get. Now, one of the other things I mentioned yesterday, as part of the system, is that over on this side I have the radio base station for the radio throttles that I showed you, and then there's a repeater located over here, and then another repeater at the far end of the basement over there. Now, the reason I did that is that this puts out a very weak signal. It's a toroidal signal pattern. It only goes out a radius of about 25 feet, and I could have, with one base station, covered the entire layout. But what happens is when you start to get to the edge of the toroid, various things like the people down here or these columns that are boxed in, the 4 columns around the layout, they can interrupt the signal. So what I did is I actually did a little bit of terrain masking from my days doing radar prediction charts. I essentially took the floor plan of the layout and plotted it out to scale with all the columns and obstacles in it, and then played around with the location of the base station and the 2 repeaters to try to find optimal placement for all 3 units so that I could get best overlapping coverage. And as it worked out, probably 95–96% of the basement where I'm operating with the radio throttles, they will be talking to at least 1 repeater and a base station, or 2 repeaters. And many locations will be talking to all 3, which is fine. That just gives redundant coverage. There's only a very small amount of the areas where it will only be talking to 1 repeater or the base station, and those areas are actually immediately adjacent to the repeater. They're within like 5 feet of the repeater and base station, so that's an almost certain contact. So I feel pretty good about this, and so far what I've been able to do is walk around and just test what little bit I'm able to set up with this, and it seems to be working very well. But this is something you need to pay attention to, particularly if you have a layout like mine that's covering about 650 square feet. You have to watch this closely. As you can see on here, this is the radius, ring radius for the range, and this is a repeater here. That happens to be the repeater over there, and this is its radius that goes almost to the back wall. About where this sky backdrop is here is the effective limit of the radius. Of course, that's pretty variable, but you get the idea. So with that, I will go get set up to show you the last part of what I'm doing out here, and hopefully I'll be able to have this posted in a couple days. Okay, while I was waiting for North Coast Engineering to finish that cable that I needed, I just received it in the mail yesterday, I actually started on the next phase of the layout, and that's going to be the construction of the main line and the branch line that goes around the rest of the layout that connects to both ends of the storage yard. And what I've been doing here, this is a real common technique that we use. I mentioned this L-girder construction that is very popular in model railroading. So you have an L-girder here supported by legs, and these joists that go across. And this is a very flexible construction because you can develop all kinds of interesting shapes to the layout. You're not constrained to a rectangular or square sheet of plywood. You can do curving edges and everything, and you can see there's a broad sweeping curve here, and it's very easily modified if you want to change things later on. It goes together very quickly. In fact, I built this entire under the bench work here, the L girder and the joists, in a period of about a month, just working an hour here, an hour there. It just was used the 3/4 inch birch plywood that I ripped into boards, which is actually stronger than a board and more dimensionally stable and dimensionally accurate, and made L girders from that. The legs are vertical L girders of 1/2 inch plywood that's very strong. They're as strong or stronger than a 2x2, just in this using plywood to make an L girder. And then to these joists out here, you see, we put in what we call risers and cleats. Okay, the vertical portion is a riser, the horizontal portion is a cleat. And this is where I actually attach the sub roadbed. And the sub roadbed on the scenic portion of the layout obviously is going to have grades up and down. It'll have scenery, terrain, mountains. That's not happening anytime soon, but it'll be coming. And using this, you're able to work around it with your scenery. It's also really handy for running all your wiring, because I'll be running that wiring and connecting the track feed leads before anything else, once the sub roadbed and the track is on here, and it's just all open and exposed and easy to do, and I'll be able to route it in such a way that if I need to get at it once the layout is completed, it'll all be visible to me underneath, so I'm labeling everything. And the way this works with this roadbed, the sub roadbed, is here I've got 3/16 inch masonite that I've ripped into 1-inch strips, 1-inch wide strips, 4x8 sheet. And this is a real common way we do this. This is what we call spline roadbed, and I mentioned this in an earlier episode. And we take these strips, and you notice in these cleats that I've got on this lower level, which is the main line, I've got these cotter pins stuck in here at the exact center line of the cleat. Now these cleats are set up at the center line, exactly where I want the center line of the main line or the track to be, whatever track I'm talking about. And to these, what I will do to build up the sub roadbed is take these strips of masonite like this, bend it to shape, okay? Start with the first strip, you can see it bends nicely, and then add a second strip to that, glue it in place. Okay, you overlap the ends, you don't run them the same length. And put the second strip in. This is one side. The inside here is on the center line of the track. And then this third strip, and there'll be 3, okay? And they will all be glued together. Okay, and once that glue sets up, I will secure this to the cleat and then build in the roadbed from the other side. Now, 6 of these wide doesn't make for the full width of the roadbed going on top of it, but it does get underneath all the track. And when I build out further from here, I won't use a continuous strip. I'll put little spacers in and then put a continuous strip out from there, so that'll expand this. But this will support the center of the roadbed. One of the nice things about using spline roadbed, as I mentioned when I was talking about the layout of the staging yard, is that it automatically conforms to a horizontal easement curve. Remember I talked about spiral easements and how we don't go directly into the sharpest radius of the curve. And when you use these splines, they make a beautiful curve in here. And you can see there's a nice aspect to the curve here. This is the main line down here in this level, and up here you see I'm putting in the risers for the branch line, and there will be a branch line that will break off at a place I'm calling Warrenville Junction and come around here and climb higher. As this is going lower, this will climb higher. This is a mountainous area, and then it'll break through the backdrop, and there will be a second level smaller staging yard that will represent a lumber company, a lumber operation in the mountains beyond the area of the layout. So part of my operation will be running trains out of the main town around through Warrenville Junction, local trains, and then they will break off and go up the branch line to take traffic to the lumberyard. And this is a very handy way to have some more fun with the layout, to add some operational spice. Now, one of the things I'm doing that I like about the spline roadbed and the L girder riser and cleat construction is you can very exactly work your grades. This is very handy. I'm working on a grade standard, percentage grade standard that is common to railroads. And one of the ways I'm doing this is by, the way we do it engineering wise, is by percent of grade rise over run. And I've got this handy little device that I got a number of years ago for general carpentry work. It's a combination laser level and digital level, and it'll fire a laser beam out at a level line calibrated to the level, but I can set it on things and I can express the setting in a number of ways. Now I have it set here to show percent slope. And between these two risers, I have approximately a 2% slope. It takes a little while to set up. The number jumps around a little bit as it's continually measuring. Right now, it's exactly at 2%. The nice thing about this is, if I want to go a continuous 2% slope, I just ought to measure between each set of risers as I go up, and that'll just give me a constant 2% slope. The other nice thing about it is, in the same sense that we use easements on a horizontal curve to ease the transition into the curve, in railroads and roads, they also use a vertical easement. Okay, because you don't go directly into the sharpest degree of the slope you're going into, but you gradually increase the slope. And the nice thing about using this digital level is that I can gradually increase the percentage until I get to the desired gradient that I want for the main line. And 2% is a pretty good gradient for a main line. The branch line is going to have gradients as high as about 2.5 to 2.7%, which is going to add some operational challenges, which will be fun. The nice feature about this too is that when you go into a curve here and you measure the gradient, you're going to get the gradient, but you have to remember that the track is actually going to travel a little bit further. Okay, so while the vertical change is going to be according to this rise over run, the run itself is going to be longer. Well, that effectively reduces slightly the percentage of grade along any curve. And that's a trick that they use in real railroads. It's called a compensated grade, because when a train goes into a curve on a rise, there's more resistance. There's more rolling resistance, the physics of pulling against the train. So what real railroads do is, when they go into curves in a section where they're going uphill, they actually use what's called a compensated grade. So when you hear a 2% compensated grade on a certain radius, you know that what is actually, the train is probably facing about a 1.8% gradient. So it's very realistic. It's the way they do it in the real railroads, and the nice thing about this kind of construction, you can copy exactly how they do it here. One detail I needed to mention about the staging yard, you may have noticed in there that you can see wires exposed and everything. It's not going to be scenic. The track obviously is laid on a sheets of Homasote. You can see the feeder wires. Well, that's just the staging yard. It's the behind the scenes. It's think of it as the backstage, where you see the backside of all the stage props. The main thing I was going for in the staging yard is durability, reliability, so that my equipment would operate properly, and I just want it to be done well from an engineering standpoint. So staging yards on model railroads don't tend to look very much like the real world, and so that's the way that's going to stay there. Plus, I'm using a heavier grade of track back there that will help with minimizing derailments and handling all the equipment. The track that I'm using out on the main part of the layout is what we call Code 83, which is a smaller profile of rail, but which very closely approximates 130 to 135 pound rail, which is common railroad weight for mainline trackage and some branch line trackage, so it'll look a lot more realistic. So with that, I'd like to show you a video that we did last weekend when our granddaughter Edie came over.
He's coming. Look, his headlights on. See it?
Yeah.
You want to blow the whistle? Edie? Push this button, you'll hear the horn. A little more, you have to push a little harder. It's the bell. Look, here he comes.
Whoa!
You know, if you wave at the engineer, they'll blow the horn for you. Why don't you wave at him? Watch this. He's going to couple up to these cars here. Look over here.
He's gonna go through these arches, and then he'll go all the way and he's gonna get the seal we get the seal.
Ready now? Here he go. Here he goes. He's going to start off. Hear the engine get louder? Here he comes.
Here he comes. Here he comes. Whoa!
Look at this. What do you think?
I think it's cool. Is the driver go? Is the driver driving the train?